In question 7 we have a car battery with an EMF of 12 volts and an internal resistance of 5.0 times 10 to the minus 3 ohms. In A part 1 we need to explain what is meant by the EMF of the battery. Well, the EMF, or electromotive force, is the potential difference when no current flows. Alternatively, we can say it is the work done by the battery per unit charge. In part 2 we need to explain what is meant by the internal resistance of the battery. Well, the internal resistance is the resistance of the materials within the battery. This internal resistance causes a loss of potential difference per unit current. In B part 1, the battery is used to provide the starter motor of a car with a current of 800 amps, and we need to calculate the potential difference across the terminals of the battery. Well, for this we can use this equation, which, expanding out the brackets, gives this, but this term IR, with big R being the external or load resistance, is simply the terminal potential difference V, so we can write that the EMF is equal to V plus IR, where little r is the internal resistance. Rearranging, we get V is equal to EMF minus IR. Putting in the values gives a potential difference of 8.0 volts. In part 2 we need to calculate the rate of dissipation of energy due to the internal resistance in the battery. Well, for this we can use power is equal to current squared times resistance, in this case the internal resistance. Putting in the values gives a power of 3200 watts. And finally, in C we need to state and explain the effect of using a battery with a much higher internal resistance. Well, a much higher internal resistance would produce a much smaller current. This is less likely to be able to start the car.